Okay, so didn't quite get done with 48, but when I connect these dots, starting at 7.4 and then going down 6 over 10, that line looks, bless you, looks very good with my data. That's a pretty good approximation. So let's see why B doesn't work. So 6.7 is going to be right about there. And then my slope here is negative 0.7, which is down 7 over 10. So down 7 is 1, 2, 3, 4, 5, 6, 7 over 10. So that's about there. So you can see when I connect this here, yeah, that doesn't really model my data at all. Let me move the screen one so you can see. Way too low. This next one is a slope of negative 1 starting at 11. So 11's about there. And then I want to go down 1 over 1, down 1 over 1. You can see that's not going to work. And then starting at 7.8, let me get rid of these other ones. Starting at 7.8 is about there. And then I'm going down 8 to the right 10. So 1, 2, 3, 4, 5, 6, 7, 8 to the right 10 is there. And then connecting that. Let me fix this line a little bit. Yep, see, just a little too low. Isn't really close to any of those dots up there. So I would say yes, A is the best one. Okay, down to some exponents. So in number 49, this whole entire quantity is negative. So I'm going to put that whole entire quantity down in the denominator. And it's going to make this negative 1 a positive 1. Then I'm going to take my negative exponents and move them to the numerator to make them positive. So I have x to the second, y to the fourth divided by 9. And there's my answer for 49. Okay, 50, I'm multiplying. So 8 times 6 is 48. X to the fourth times x to the fifth is x to the ninth because I add those exponents together. In 51, I see a 0 power. That completely goes away because anything to the 0 power is 1. I can simplify my coefficients here that 18 divided by negative 6 is negative 3. I have c to the negative second power, which is going to come up to the numerator and join with the c to the third power. So that will make c to the fifth power. I need to erase this just to make sure. Okay, so yeah, d is only to the first power in this numerator. So I have a first power and then a fifth power in the denominator. So 1 minus 5 is negative 4. So that 4 is going to go into the denominator. Another way to think of this is if I have 1d in the numerator and 5 in the denominator, when I cancel one pair of them out, I'm only left with 4 of them down in the denominator. This whole entire thing is to the negative 1 power. So the entire fraction is going to flip. So 2x to the fifth, y to the negative fourth, x to the negative third, y squared. So that makes all of this go to the first power positive. Now I'm going to do my switching. So x to the negative 3 is going to move down to the denominator and join with the x to the fifth. And y to the negative 4 is going to come up to the numerator and join with the y to the second, multiplying the bases, which means I add the exponents. Okay, 53. 32 divided by negative 8 is negative 4. I have 1x in the numerator, and I have 2 being multiplied in the denominator. Canceling one pair of them out leaves 1 in the denominator. With my y's, I have 4 y's in the numerator. I have 1 in the denominator. Canceling one pair of those out leaves 3 y's in the numerator. Next part of the problem, -2 divided by -4 is 1/2. So 1/2, positive. And then I have an x in the numerator. And then I have y squared in the numerator. And I have y to the 6th in the denominator. Canceling out 2 pairs leaves me 4 y's in the denominator. Okay, I'm going to continue down here, just continuing. I have -4 divided by -2 is -2. 3 y's now in the numerator, 4 y's down in the denominator. I have 1 y left in the denominator. And then I have an x in both. X in both. That'll cancel out. So that's my answer. Okay, last one with exponents. So anything to the 0 power is 1. That whole term, or not term, sorry, that whole quantity cancels out. This y to the 0 is going to cancel out as well. Not the whole thing, just the y to the 0. So now I have 3y to the 5th written out 2 times because it's squared. Then I have 2 written out 3 times. These are all multiplications. So 3 times 3 is 9, and 2 times 2 times 2 is 8. 9 times 8, 72. Y to the 5th, y to the 5th is going to give me y to the 10th power. Okay, write the first 4 terms in the sequence. So what I need to do is plug in the numbers 1, 2, 3, and 4. So 30 minus 4 times 1, that's 26. 30 minus 4 times 2, that's 22. 30 minus 4 times 3, that's 18. And 30 minus 4 times 4, that's 14. You'll notice that these are going down by 4 every time, and that's because the slope is -4. Since I have a plus sign right here, I'm going to assume that this next one is going to increase as I go. So let's see. 8 plus 3 times 1. 8 plus 3 times 2. 8 plus 3 times 3. And 8 plus 3 times 4. And I see I'm going up by 3's, and that's because my slope is 3. Antonio has a savings account. The graph below shows the amount in his account with respect to time. What's the value and the meaning of the slope? Okay, so it looks like we're going down 600 and over to the right 8. So -600 divided by 8. Well, they're both divisible by 2. Still both divisible by 2. Still both divisible by 2. So the value of the slope is -75, and it means the amount decreases by $75 per month. The y-intercept is 600, and that's where he started. Zero, 600. That's his starting amount. The 0 means the x-intercept. So where does that happen? It looks like it's at 8. And 8 means in 8 months, he's out of money. He'll have $0. Okay, which of the lines have a slope of 0? We're looking for the horizontal. 0. B.